Hello everyone, I hope you're doing well and welcome back to my channel. Today I will try to answer one particular request which had to do with the application of the inverse or reverse RIAA circuit board as a test tool for testing your phono stage. What you see now on the screen is a website of this company, Acoustic. It's a Canadian company making that gizmo. And you can see two versions of that circuit board shown here. Why two versions? Well, the one on top has also tail deck equalization on top of the RIAA, hence this switch. The one on the bottom does not have the tail deck circuit. Therefore, the one on the bottom will be a little bit less expensive, so it's up to you which one to buy. But as you can see here, the prices are very reasonable for this type of circuit. Remember, you had to develop circuit board, the circuit diagram, precise calculation of the components and selection and whatnot, testing. So overall, I would rate this price as very, very reasonable. I don't know what's happening today in the world economy, but that's the price I paid last time I ordered this device. And I don't regret it one bit. Do I need it in my work? No. And I will show you why a little bit later. But I bought it out of curiosity. And I like it. Since I bought it, I of course tested some of my phono stages against this device, and I got very good results. Of course, I also tested it against equalization curve that's stored in my audio precision system. And that one is as precise as it gets because it is digitally, programmatically generated. But as I am going to show you in a minute, the results of those two are incredibly close. Basically meaning that this particular inexpensive solution is indeed very, very good one. But let's go step by step. Today's test subject will be one of my recent head preamps. And as you can see here, it contains the RIAA position. And that's what we're going to be testing. The strong point of this preamp is not phono equalization, it's basically the tape equalization. But since it's there, we might as well test it. And we're going to test it both ways. One will be by using this device to program the curve, and the other one will be by using the audio precision system's internal RIAA inverse equalization. So for the first run, I have connected the circuit in series with my signal that comes from the audio precision system. It is linear frequency signal coming here, and what comes out is inverse RIAA equalized signal. So the idea is, if I apply this signal to my phono stage, what am I going to get at the output? And let's find out. As you look at the system screen, specifically here, you will see the word normal. And that means the signal as it comes from the test system is not equalized in any way. It's a linear phase, linear frequency response signal. So the idea is, after going through this small board, it will become inverse RIAA equalized, and then it goes through the phono stage, which has its own RIAA equalization. And hopefully they're going to cancel each other. And the output should be flat. Well, let's see. I click Start button, and here we are seeing the output frequency response of the system consisting of this inverse II equalization board plus the phono stage. And I rate this response as very, very good. As you can see, there is a very small amount of drop in high frequencies, but it's insignificant. It's on the order of maybe 1/10 of a dB or less. And there is this drop at low frequency, which is also can be totally ignored because it's only about 0.6 dBs at 20 Hertz frequency. And as we know, phono stages very often introduce ramble filter, so you have to sacrifice a little bit on the lower end. But this type of sacrifice, 0.6 dB at 20 Hertz, is again truly insignificant. So as you can see now, I disconnected the inputs from this circuit, and I'm going to plug it into the inputs of my phono stage directly. It is done, so let's proceed with the test. At this point, I had to make a couple of changes to my test system screen. One was the signal magnitude. It is just 2 millivolts now. I don't know if you noticed, previously it was 220 millivolts. And the reason is that this circuit, equalization circuit, attenuates signal. That's the only way it can work, because it is a truly passive component. So when you look at the output signal of this little board, it can be anywhere between 40 and 60 dB attenuated at 1 kilohertz with respect to the input signal. So you need much more incoming signal. But now, since we're back to the active circuit and the audio precision generates its own signal, we don't need as much. So we can go with 2 millivolts. And that will provide about the same magnitude. So hopefully the two sets of curves will fall very close together, so we would be able to analyze their shapes and whatnot. The other difference is, of course, now I switch to equalization. Previously it was normal, no equalization at all, but now it is pre-emphasized to RIAA. So like I said, the net result again should be flat. And let's see what it is. Well, if you compare the two curves, the one obtained with this board, that's one on top, and the one obtained by using the internal audio precision system pre-equalization, they look remarkably similar. Yes, there will be very small variations, but they are so small you can simply ignore them. Let's consider this line and that line. They're almost identical. This goes flat, and this has a little bit of rise, but that rise on the order of 1/100th of a dB difference. Totally ignorable. The main character at the bottom remains the same, which also tells me that the passive circuit is incredibly accurate. Remember, the accuracy of the passive circuit is going to be affected by external connection resistances. Input resistance and output resistance of whatever you connect to that little gizmo is going to affect its accuracy. Right now I'm running at 100 kilo ohm input resistance, as can be shown here, 100 kilo ohm. And output impedance is very low. I think it's on the order of 600 ohm. So as you can see now, with those parameters in place, the two curves are virtually identical. So the bottom line is, if you are expecting to be doing any testing or verification of your phono stage performance, this device at very reasonable price is extremely useful in your work. And I would definitely recommend buying it, even if you use it just occasionally. But next question might be, what does it look all by itself like in frequency response area? So we're talking about inverse RIAA, but what is it? Okay, let's see what this little board does by itself. So now I have this board connected directly between inputs and outputs of the test system. No active device is used at this point. It is purely this little board doing all the equalization or frequency correction. So let us see what it is.